next talk is Enterprise Flight into DevOps Space, and actually Mark over lunch asked me if I had any references to Star Trek, and I said no, unfortunately. And the reason for that is quite easy, is that I really want to show how much the word enterprise is actually being misused. And when I say Enterprise Flight, everybody thinks about Star Trek, but it's not really the Star Trek in this case. And in many of the cases, it is actually looks like a flight of a spaceship when you talk about your organizations. So, okay, it's nice that we have a one-track conference, so you probably guys by now already know who I am. I'll just in case, my name is Andrey. I'm a developer, I'm a DevOps guy. So, enterprise. How many of you guys actually work with or work for enterprises? I guess everybody, right? At the same time, for some reason, this word, enterprise, has been given so much bad reputation. So when people at the conference talk about enterprise, oh, you talk, yeah, this enterprise stuff, we don't really, yeah, it's not for us, we're a startup, whatever. So, well, at the same time, everybody works in enterprise. Because enterprise is just a simple, normal English word, which means, or in most of the cases, organization, corporation, company. And unfortunately get a big bad press. But at the same time, what people usually mean when they say enterprise, well, I found this nice term called enterprising. So something that is overcomplicated, very slow in motion, and not very efficient. So let's talk about that. And I hope you guys work in very efficient enterprises. But let me tell you the story first. And this is a made-up story, it's not a real one, but that's something that I've seen many times happening in different aspects of that happening in big and small organizations. So imagine, once upon a time, we have this nice organization which has departments. There's a development team, there's a QA team, there's a IT operations team, then of course there's management on top of that, and they live happily. They fulfill their business goals, they do the work. Everything is okay. Well, I guess quite familiar. And once upon a time, email arrives to, well, that's our hero, that's Jack. He's a system administrator, and once upon a time, manager sends him email that, well, we have this new secret project we want to start working on. Can you set up 10 development servers for us? And Jack says, yay, that's what I do. That's my job. I'll settle the servers for you. That's what, well, give me the requirements, I'll do that. And he starts working. After a couple of days, he has one server ready. Maybe he started a virtual machine. Maybe he orders some hardware. Doesn't really matter. So he sets them up. After 5 days, he's almost ready with that. And manager is kind of getting impatient. And he said, well, come on, that's a very important project for us. We really want to start working on that. When the servers are going to be ready? And Jack says, yeah, they're almost done. Just a couple of more days and you get them. At the same time, Jack works in his own department. Operations department, he has his own boss. And he also gets another mail from his boss saying that, well, we have some guidelines and rules and policies in our operations department, you have to follow them, you have to write documentation, you have to hand over everything. And Jack said, no problem, I'm finished. I filled the Excel template or whatever it is, Word template, with all the settings, all the setup, all the configuration. And here it goes. Here, get the environments. Well, in the meanwhile, developers, they start to work on those environments. Obviously, they have to do something. They have to deploy the code. And they start changing, they start sending some change requests to Jack. And because the organization is very hierarchical, very departmentalized, things are going through the management or through issue tracking system or through some indirect way. So Jack is getting CRs on his table, he's fixing them, but probably he doesn't get all the information that it needs. At some point, some of these CRs actually broke all the servers. So developers can't really deploy anymore, and they start complaining. There's a lot of blame games starting, basically. And poor Jack has to sit there Friday evening and fix all the servers, and Friday, like 4 p.m. he sends a happy mail, 4 a.m. sorry, he sends a happy mail, so now environments are fixed, now we can use them. Well, things don't get better at this point, because there are more CRs coming, more change requests, more configuration things, more updates, more deployments, application changes the architecture, then we need new software to be installed, we need new database parameters to be configured, and it's all going to Jack. It's all going to Jack, and well, he's not super happy at this point, but he's coping with that. But the problem is that environment that he's configuring, they are working. They serving probably the test clients. Developers can do some demos on them, but at the same time, the state of those environments, of those servers, is worse than down because we don't know what the state is. And documentation that was created in the beginning and probably slightly updated after that is not quite valid anymore. It's probably some part of this is probably still true, but the rest of that is not true anymore. And what we get chaos because nobody knows what's going on. And of course, things get worse, even worse, when the secret project moves into QA phase. So we add QA engineers on top of the systems, and there's more CRs coming to Jack to actually implement some changes. At some point, of course, manager says, okay, now this application is ready, somehow we made it work, somehow we tested that, somehow, let's go live. Of course, you have, at this point, you probably have already several environments for production, for pre-production, for QA, for testing, for development, whatever it is. And all of them are in the state that nobody knows. And of course, at that point, documentation is kind of thrown away because it's not really important what's there because it's completely untrue. And when go live date happens, when your application starts with customers, of course, it's becoming important to make it work. And Jack alone is not enough to support it. So a usual solution to fix that is to throw more people at that. Make more people to solve the unknown state issue. And because at some point production is becoming even more important than any other environments, then all the people start working on production. And all the other environments which are supposed to deliver quality software, people not think about them, they just are in some even more unknown state than before. And all people that are related to operations, they focus on production. So guys, how many of you have seen this kind of situations? Oh, wow. Yeah, well, me too, unfortunately. Quite a lot. And that's where DevOps actually coming in. So when you hear something like that, DevOps is not for enterprises, DevOps is for enterprises, solely for enterprises, because that's the way it should be. Okay, if we continue our story, that applications kind of running, kind of starting to serve for customers, and then we ask our operations guys, what about monitoring? Do you have monitoring? And they say, yeah, we do have it, yes. We have our solutions, we collect some metrics, but at the same time, when some obvious problem happens, operations guys don't see that. And the reason for that, because they don't know when application is misbehaving. They were not given this information from developers. So yes, they monitor the CPU, they monitor the disk space, which is, of course is important, but at the same time, it's not always important to understand how your application is functioning. So, and I've been there. Obvious problem in the environments, operations guys say it's okay, it's green, but then we get a call from a customer to the manager, and the manager, angry manager comes to everybody and says our system is down, which is definitely not a pleasant situation. Well, and I've been there, and everything you can say there is like, especially from operations side, is, well, sorry. Is there any happy ending to that? Before we understand that, we have to see where the problem is. And the problem is, as everywhere in software development and software operations, the problem is always in communication. Software is written by people, for people, and if you have any delivery issues, most likely it's miscommunication. And in the case of departmentalized organization like Jack or Jack works, and probably also the case in some of your organizations, is that information about deliverable is coming only one way. So the developers are throwing actually partial information about how to deploy the application, how to deploy, how to maintain it to operations guys, and they have to cope with that. And they never fight back. They never say, oh, you know, guys, you probably are good developers, but what you gave us is complete shit. Or they complain on the management level, the management decides that it's not really important to complain back. But that's where DevOps should actually go for. It should go for the full feedback cycle. Full feedback when operations guys actually complain and influence the way application is designed and deployed and operated. Another problem, especially again with these departments inside organizations that I see, is that developers, they more or less are following agile methodologies. They more or less agree on how to do development, but at the same time, operations, they are completely different kingdom, and they have even more like sub-kingdoms inside them, which don't talk to each other much more. So yes, it is a problem, and it sometimes happens that these two shops, they happen to talk on the level of foreign ministries instead of talking like on the level of people, which is a problem. Okay. And probably you've heard about that already. The goal for operations guys is to make the system stable. The goal for developers is to produce more changes, to be more agile. So it's always like stability versus agility fight. And these things, quite often they're looked at as antonyms, but they're not. Because what you actually want to achieve in DevOps-like organization is that you would like to have stable agility or agile stability, whatever it is. And the only way you can achieve that is by improving the communication. Okay. Another thing that also not many operations departments actually, they're not controlling that, is a metric called unplanned work. And there's a guy called Jim King, you've probably heard of him. He's organized a conference, DevOps Summit in the US. He also wrote a book, The Phoenix Project, part of that, he co-authored that. And he had this blog post about unplanned work, maybe in 2006. But that's something that actually can kill your company. Unplanned work can kill your company, easily. You have to take control of that. And that's what operations departments, operations teams, usually struggle with. Because from development point of view, it's more or less planned. We plan features, we plan new code, how do we deploy new code, we have a plan for that. From operations side, a lot of things can go unplanned. Downtime, database backups, database migrations, DDoS attacks, whatever it is, many things can go unplanned. And if you don't take control of that, or if you introduce more unplanned work from development side, which don't communicate well, then it may influence in the amount of unplanned work. And Jim has this nice chart of how the software delivery, or the way the software is organized and then deployed, can actually influence that unplanned work. So if the change rate, if you have more or less the same development team, then they produce the changes at the same rate. But at the same time, if the number of failed or unauthorized changes, the things that are done in the wrong way, without like manual way, instead of using automation, if the number of failed changes is growing, this absolutely obviously increases the amount of unplanned work. And if at some point the amount of unplanned work is going above the amount of time you actually have, well, that's the point of death. That's where you die, as an organization, of course. Another thing that influences unplanned work is the amount of unique configurations that you have to handle. And here we can talk about different operating systems you have to support, different databases, different application servers, different middleware components, different Java versions, Ruby versions, whatever. If you have too many configuration options that you have to support, then obviously you can apply unlimited level of mastery to each one of them. And if this mastery for each configuration that you have is dropping, because you can be skillful in everything, you only can be skillful in a few things. But if you have too many configurations, then the mastery for each one is dropping, and of course the change success rate is also dropping, and this will also increase the amount of unplanned work. So yeah, that's where DevOps should help. That's where DevOps is actually stepping in and helping, not startups, not high-end organizations like Google or Facebook. It helps real enterprises which have faced real problems and solve real stuff for the real customers. So communication should be fixed first. It's not about the tools. Tools are there. Tools are working fine. You fix communication beforehand. And it really should look like that. Well, you still play on different teams like devs and ops, but at the same time, you should know the rules, you should play by the rules, and there should be a constant feedback from back and forth. That's what most enterprises, like slow enterprises, they don't really get. And it should be a shared responsibility from all teams. So everybody should understand that we are contributing not just to our work, we're contributing to the business side of things. And if the amount of failed and unauthorized changes is dropping, obviously the amount of unplanned work is going down, and then you can focus more on other stuff like automation and improving the process. The same is true about number of unique configurations. If you have less configurations to support, if you can agree inside your organization that you only use Macs, for example, for laptops, and Linux is for production environments, and use only specific operating system on them, this will help you to simplify the processes. You won't need to support a lot of different setups, a lot of different skill sets inside the company. And this, of course, will reduce the amount of plan work because you can focus. Okay, great. DevOps is something that will save enterprises, and that's something that it should. But at the same time, it meets a bit of resistance because well, DevOps as well as enterprise itself, two words, they can be overused. And DevOps is still sold as a silver bullet, but as we know, there's no silver bullet that can help. And first of all, it's highly misunderstood. I've heard a lot of things about managers are searching for DevOps engineers. Guys, if you don't know it yet, DevOps engineers do not exist. Because DevOps is not a skill of a person, it's a skill of a team, of organization. It's how things work inside the organization, but it's not. If you know some tools like Pavel or Chef, or you know how Jenkins works, it doesn't mean you're a DevOps engineer. It means that you know the tools, but it doesn't make you a DevOps engineer, because this is something that doesn't exist. So, and of course, all this stuff led a bit to misunderstanding and rejection from devs and ops, because they don't want to be called something that they don't understand. But yeah, that's something that should be implemented on top of the organization, not as a skill of a single person. And therefore, there's a nice blog post from a guy called Matthew Skelton, who defined, also he works as a DevOps consultant, automation consultant, and he observed quite many different setups, how DevOps can be implemented inside enterprises, inside organizations, and he collected a set of anti-types and types of good DevOps and bad DevOps, and that's what I'm going to show you now. So yeah, you can just search for him or search for devopstopology.com, where all this is described as well. So first, let's go through anti-types. Yeah, that's basically the first anti-type, dev and ops silos, but that's where Jack is basically working. We have a dev team, we have an ops team, there's absolutely no connection between them. They just throw artifacts and they work in completely different life cycles, completely different workflows. So this is a bad thing. Another bad thing that, well, some organizations actually try to implement is they think, okay, now we've heard about DevOps, let's implement DevOps. Let's put our best guys to a DevOps team and let them implement everything. The problem is that we introduced just another silo. And well, actually, Edward maybe can tell you more about that. When there's a target team that works on the pipeline, on automation, and the other guys still have to support the real application, when finally this target team introduces the pipeline and said, well, no, that's what you should use. Of course, you meet rejection from those guys, because they were working for several months deploying stuff and actually doing work, and suddenly they get a silver bullet, which doesn't work, so just reject it. So having a DevOps team is actually it's an anti-pattern. Another one, anti-type C, dev don't need ops. And that's also sometimes happens when developers think that those ops guys, they probably are too arrogant and they don't know how we work. And we have so many APIs available, so we just use the APIs. And we just do everything ourselves. And when it comes to real production, then yeah, there's a huge chance that things like backups and data migrations and security will actually fail, because there's obviously not everybody in that team have enough background in those topics, but ops guys usually have. So don't ignore operations. Another part, another anti-type which is quite similar to the previous one, is that inside the dev team, you put another sub-team that does the tooling. Like we have Jenkins guys, you have Puppet guys, you have whatnot, and then they're focusing on that. So they have, it's their responsibility. But at the same time, the operations, the production system is still managed in a different way. So that's the wrong thing, because the same procedures you use in development and staging should be used in production. Otherwise, it doesn't really make sense. Another wrong way of doing things is that when you still have silos like development and operations, and you basically offload all the tooling part to the operations guys. So you say, it's now your responsibility to set up Jenkins, it's now your responsibility to configure Puppet, but you don't give them enough information or skills, and they still do it in their way, but there's no connection, so you still get some wrong information from both sides. And that's what I actually heard quite a lot when people who were calling them sysadmins before, now they call them DevOps engineers, and that's because somebody put them in this team and told them, now you do Puppet and Jenkins, and that's your job. Well, you're still sysadmin. Okay, now let's look at the good types. And the good type, the first good type is, of course, when you have this collaboration between two parts, when they have a full understanding of the requirements of each other, and they have good communication between each other, and when everybody takes into consideration the needs of the development team, the needs of operation team, and then they work together in concert. That's a good DevOps collaboration. Type 2, which is probably good enough for single product companies like Facebook or Google, where everybody is so much into the product that they develop, so there's not much difference between developer and operations, and they work together, or they share responsibilities very much. So this is where segregation is quite big. So yeah, this is DevOps Type 2, which is very similar to Type 1, just the segregation is much bigger. Type 3 is that if you have complete understanding of your operational requirements, if you know exactly that, for example, Amazon is giving you all the things that you want, and you know that that's what you need from development point of view, then this can actually work when you outsource your operations to infrastructure as a service company like Amazon or Google or Microsoft. But the only requirement here is that in this part, you actually have a complete understanding of all the processes that need to be implemented. Because it looks very much similar to, I think, anti-type C, where you have devs don't need ops. But to some extent, especially for smaller companies, this may work. But the only requirement that you have to know the actual infrastructure requirements that you put on this, the infrastructure as a service. Also, this, again, for smaller companies, DevOps can work as an external service when you have a company that is specializing in operations and specializing in supporting automation pipelines and all that stuff, and you have a joint team together that have a good communication channel and good understanding of the requirements. Then it can also work as a DevOps topology. But again, it's only when this company is small in size and when this company is fulfilling the requirements, and you have a joint team in there. And the last type, which again is quite similar to the anti-type B, is that we still have a DevOps team. But the purpose of that DevOps team is not to create something and then give it immediately, like you have a waterfall project and give it after 6 months. The purpose of that team is to leverage the communication between the devs and ops, and to set up, maybe help setting up the processes, help setting up the tools, but at the same time their requirement is that they actually do education, and they do introduction, they do talking a lot about what is going to happen, and then they don't do it at once, they do it gradually. So, and that team should have an expiry date. So the main purpose for that is that the gravity, they should increase the gravity between the two teams, and then eventually that gravity should smash the DevOps team, and they should fade into the other teams and move to the type 1 basically. This could be a good one. Does this make sense? Okay. Do you have any questions so far? No. Okay. I'm going to finish with my first part of this presentation, and the second part of this presentation will be again quick hints where devs and ops can start helping each other, and yeah, they're really simple ones. So first of all, of course, you have to talk more. If you have devs and ops sitting in different rooms and you don't have even conference calls with each other, probably you should do that. And you should really talk more about that. You should talk more about the requirements, about specifics of how applications should be deployed, how it should be configured, how it should be logged, and all that stuff, monitored. All this information should be visible to all parts. Of course, it should be shared, and the best way to share is to share everything you can, and to share it with the help version control, obviously. So some hints for developers who work in this kind of environments, is that, well, first of all, don't ignore operations. They are real people. They are good guys, most of them, yeah, they have their requirements, they have different goals, but it doesn't mean that they're bad guys. And the first thing, and Samir actually was mentioning that already, the first thing that developers can help is by at least thinking about the logging. Because unfortunately I've seen so many like enterprise applications that are logging in a very inconsistent way, and it's very hard for operations to actually make sense out of what your application logs. So if you have, and login is like it's another interface to your application. It's basically contributing to your operations experience. If you have a bad login, you have a lot of noisy logs, then of course it will not help your operations guys to understand what's going on with the application, because this will be the first resort where the operation can probably look into when they have a problem. They will look into the logs, and everything is important here, like login level message, and frequency of login. It can help or it can disturb, and this always could be someone on the other side who will actually read your logs. Yeah, Samir was talking about that logs should be machine readable, and this probably is machine readable logs, but it's not human readable. So I think, in my opinion, especially if you don't really go into event sourcing and event logging, but you still produce logs that have to be parsed by humans, you have to make sure that they're actually human readable. Another thing that actually quite often goes wrong in enterprise applications is configuration. I've seen so many applications that have a lot of parameters which are badly named or inconsistently named or have misleading name. And of course it doesn't help operations guys to configure those applications because yeah, they're just illogical. And configuration, obviously, all the parameters that you provide for your application, like environment variables, configuration files, key values that you read from configuration server, they should be consistent and they should be understandable, because it's another interface. It's another interface to your application, and interface should be understandable. So yeah, probably you know from where it's taken. It's Windows registry, and that's the bad way to name parameters. So yeah, for some reason we have here don't load desktop, and God knows what is mmcpl. Power config sound, well, yeah, not really consistent and well-named parameters that allow to configure me the system, but at the same time, it's very hard to understand where I have to put something that contributes to my application configuration. So think about parameter naming as well. Another thing that is not often taken into account, especially in the enterprise-y world, is that application is not exposing any monitoring data or exposing very limited monitoring data. So it's something that, again, developers can help with. They can make their applications monitoring ready. They can expose protocols that their operations maybe support, like JMX or SNMP or HTTP stuff. And it's important for developers to take this into consideration when they develop applications, because if they have good monitoring, if they expose all the major KPIs of the application, then it will help. And of course, it's important to monitor vitals, but at the same time, it's important to monitor business metrics or application metrics that are important specifically for this application, and notify your operations guys about them. So make them aware of that. Of course, as a developer also, I would say that developers should create dashboards. It's not only operations responsibility, it also should be development responsibility, because they know the applications better. They know what could go wrong. And why can't they create a dashboard, maybe even built into the application, to actually expose some data? And that dashboard can be either shared as code or be built into application. It will help. And if you can develop that dashboard as your application develops, as your components add, as you add more stuff into your services, if you also create a dashboard for that, it will help developers, operations guys. Also, it's quite important to make an early alignment with your operations guys, because if you don't, then something like that can happen. A number of issues may go up when you go to QA phase, but when QA phase says, when QA guys say that, okay, now we're fine, but because nothing on integration level was tested before, when you go to operations, you get more issues. So try to align, as a developer, try to align the requirements for the application early enough and make your application monitorable, good logging, good parameters, good backwards compatibility before. It's not that hard, actually. It's not that hard, and just think about it before, and align it with the operations guys. I would say that developers should at least have an understanding of how these tools work. Publish Ansible and Salt, or in any other provisioning software that you can actually use in your organization. So I think it's quite important for developers, maybe not to write this code, but at least to understand how it works and have an ability to contribute to that. Also, for developers, maybe it's worth building something that resembles production system as much as possible, so that they can reproduce bugs, they can benefit from the same setup, they can contribute to the configuration code. So build a clone production environment locally. Maybe scale down, but can be clone. Another thing that I think I mentioned in my previous talk is that try to use package managers to provide input for your operations guys. Because I've seen many times that application is given in disassembled form. You give it like this jar, that gem, this configuration file, that configuration file, and operations guys are supposed to assemble it back together. Then you can actually, as a developer, just learn how different package managers work and provide operations guys a package that they can already deploy, like RPM, DAP, whatever it is, or even a Docker image. Why not? So yeah, artifact repositories are very good for that. So if you can share artifacts and you can version them, then that should be an easy way for your operations guys to deploy to production. And everything should be in version control. Automation over documentation, I already mentioned that. It's quite important because it's more live code, live automation that outlives any documentation that you can create. And automate everything. There's nothing new here. Some hints for operations guys, because they are kind of on the other side of DevOps pipeline. Well, first of all, get developers to solve production problems. Because one, developers will understand what kind of issues operations guys are going through to fix the problems in production. They will probably also start thinking about how to design their applications better. So get those 10 developers to solve the production problems. And also, yeah, of course, look at how they did that and do some post-mortem analysis. So next time it's easier for debugging and everything. Yeah, monitoring is, of course, so it's important on both sides. So as a operations guy, you can also create additional dashboards for something that is important for on the infrastructure level. Analyze data, create alerts. That's important. Logging should be, logging data should be always aggregated, because yeah, nowadays nobody goes to each server and grabs the logs. It should be a single point where your application sends the data and has an ability to go through the logs, analyze them, and Elk Stack is definitely a good solution there. Also, Elk or any other log aggregation solution can be a way to actually clean your logs, because, well, at least in the enterprise applications, I've seen many times that applications just log too much or log a lot of noise. And if you have a tool which aggregates data in a single place, you can always go through that and see, okay, this log is there, but it doesn't make sense, doesn't help anybody, just noise. File a ticket to developers. Please remove this log statement from application. It's not needed there. We don't need useless logs. We need only useful ones. And that should be probably a periodic process for everybody to go through. And of course, learn how to use provisioning software. If you still don't, in 2016, that's a problem. And infrastructure is code and should be expressed as code. So learn how the code works as an operations guy and put everything in version control. Actually, sometimes have a challenge forcing sysadmins to push stuff into version control. But yeah, it should be there. Code must live in version control. And anything that happens in production, like configuration changes or some parameters adjustments, they should be ported back to developers or back to dev environments, so that you have alignment between the two, and you catch issues as fast as possible because you have the same environment, you don't have unique environments. And as operations guy, you of course have to be prepared for disaster, because it will happen no matter what. So think about backups, think about capacity planning, think about proper monitoring and alerting. All that stuff is quite important. Okay, I think I'm done. Just some books to recommend. This is probably, how many of you guys have read that book? And how many of you guys heard about the book? Okay. Well, if you haven't read it or you haven't heard it, it's quite a nice introduction into DevOps. And the thing is, it's not a technical book. It's a fictional book. It's a story about the CTO in a big enterprise, which tries to solve the issues inside the enterprise with the help of DevOps, of course. And it's written by Jim King, whom I mentioned already. So it's quite nice, quite easy to read. I think I read it like in one evening, so quite fun as well. And you'll probably recognize some other patterns that you've seen already in the enterprises. Continuous delivery is definitely worth reading, maybe from a technical point of view, but also from pipeline point of view, defining pipelines. And I honestly think that continuous delivery and DevOps is something that usually comes hand to hand. They have to exist together. You can't really implement continuous delivery if you don't have proper DevOps culture in your organization. And usually if you implement DevOps culture, you end up implementing continuous delivery. So the book is important. This one is kind of similar to continuous delivery. I think it was released about the same time as continuous delivery, but looking at that, software delivery in a different angle, but also quite interesting. And yeah, this one is just a guide for anyone to understand where disaster is coming from. Some popular DevOps blogs, and any questions?
Thanks for the great presentation. Regarding the first part, I guess it's regarding the first part, maybe also for the second. You said, or you showed a picture of the archetypes where we have the silo in between dev and ops.
Yeah.
What about the situation of multiple site development and also multiple very heterogeneous operations, so data centers that have different processes, different, let's say, interfaces for deployments and stuff. What should you really do about, because the dev part doesn't want to care about that. Mm-hmm. So who should care about that?
Well, I guess the management. They at least should understand that by limiting the ways of how developers can cooperate with operations, they limit the speed, and they always face the issues with, because this kind of setups, I've seen them many times. When you have the operations company in one country, developing company in another country, and they just throw artifacts to each other, and probably, at least in the beginning, they should gather together and agree upon how they do that. Agree upon the format of the deliverables, agree upon how they propagate the changes, because yeah, it's probably going to be hard to break this boundary. But at least from management point of view, they should gather those people together and have at least some formal or informal conversation on how they do that, and maybe have set up some channel that they can call each other and stuff like that. Because yeah, if there's nothing like that, then problems will happen.
Well, the situation is that collaboration works great in between, yeah, also dev and ops, but we have the multiple ops, and with all the different data centers, we work together. That's no problem, but in a different way that we have to work together. So there is the kind of, let's say, abstraction that is needed for the devs, so that they have one process for getting stuff deployed, for example. And this now is done with people. So would you say is it then the pattern with the temporary DevOps silo in between that is needed, or how would it match?
Well, but it depends on how strong is the boundary between these organizations. If you can really break it, I would say you have to break it, because this will make the whole process more efficient. But if it's set up in stone and we have like a huge contract that's saying we do it like that, and we have this organization is only accepting artifacts in this way, then nothing you can do really, because that's the way the organizations work. But if you have a chance to influence that, then you probably should. And that's also what management should probably understand better. If they really want to get faster, if they really want to not spend time on producing deliverables for 5 different types of operations teams, and they really want to save some money on that, then probably they should do differently. But I mean, and DevOps probably is not for every organization, and with this kind of multi-site organizations, it will not work as good as for organizations where you can set up the communication channels and we can influence the way things are deployed. So yeah, DevOps is not absolutely for everything, but in some cases you can influence it. In some cases it's just so much strict, the boundary is so strong that it only can be broken on top level somewhere.
Yeah, sure. And second question, regarding the point you said, well, earlier in the presentation today we heard about the monolith versus microservice architectures, and somehow a conclusion was that you always have a little bit of both, or very often you have both. So regarding the dependencies, what would you say, who should care about the dependencies in operations then? Is it more the developer, or is it more someone on the operations side, or
well, I think both of them. Yeah. Well, of course, operations guys should be aware of what are the dependencies, and developers should have a freedom to actually introduce a dependency if they need that.
Sure.
And the only way to kind of have some common ground is probably express those dependencies in form of code, and it could be Puppet or Chef, it could be Terraform, it could be something else. But if you can put this common ground and use some tool that allows you to express this, and from where dependencies are being taken from, and how the services are depending on each other, then you already have more than enough to actually handle that.
Sure, if you have the degree of automation, the degree of expressiveness of dependencies, but with a very heterogeneous system with many tiers, many different subsystems, yeah, there is a lot of stuff to do manually regarding dependency management, and this is where, again, people in between come into place, where developers don't want to care about all the different subsystems they just use, and operations say, well, they cannot do something to describe those dependencies, they have to work with it. So again, someone in between.
Yeah, I mean, I'm not saying that you should go to only to fully automation if there's strong boundaries like that. If something that is not cannot be automated, or for some reason is too expensive to automate, or it's just legacy software that nobody wants to touch, then well, you have to make some workarounds, obviously, and yeah, maybe just depend on that to some extent. And of course, it's usually, well, for this kind of legacy system, you have a team which supports the legacy system, and it's their responsibility to give new endpoints, new deployments of, let's say, old database or old COBOL deployment, whatever it is, and it's their responsibility to give you that. And if you have a defined process there, if they can actually give you that, then yeah, that's the only way to do that. And probably if you have to use those components in a test environment, you can potentially mock them, or have some test level for them so that you can use them without depending on those guys. Yeah, it complicates things, and the problem is really that on an organizational level, people don't want to touch that old stuff or to rewrite that old stuff, maybe because it's expensive, maybe because it's just lack of knowledge that doesn't help to reflect that. But it doesn't mean that the problem should not be solved. It should be solved somehow, maybe at some point, and there should be probably a plan to regrow that system to make the organization perform faster. And there's always a trade-off. And it's more like a management problem issue, really, where you have to make some trade-offs, but at the same time you have to be creative enough to allow the fast parts of your system, of your teams, move fast. And if this legacy system becomes a bottleneck, then obviously something is wrong, something should be changed. So yeah, there's no single answer there. It's like really should be trade-off and see which parts of your teams, organizations actually move fast and which move slow or don't need enough speed. And there's actually a conversation now going on in the DevOps community called bimodal IT, where it's like you have fast-moving teams, fast-moving components, and all the legacy stuff that don't need to be changed that often and they're kind of in a stable state. And you have different ways of managing them. And DevOps is more for like fast-moving because you have optimized for speed, minimize the feedback cycle. And the old ones, they are just, they should be there, and the operations guys just should make sure that they are up and running.
Okay, thank you very much. We should discuss that later on.
Sure. I'm here for the rest of the day, so. Okay, thank you.